My name is ARITRA SARKAR, roll number 20QD30003. So, as a part of the DIY assignment, I have used the PROTEUS software and I have modified some of the codes, sample codes that are present to generate some new features. So, first of them is the DHT22 humidity and temperature sensor. So, I have modified the code as uh, so the first part of the code that is already present in the sample code remains the same. I've just introduced some conditions for the LED lamp that is present here in the schematic capture to glow. So I have set the conditions for temperature greater than 28 degrees Celsius, and under that some sub conditions as humidity level, the relative humidity percentage greater than 60 and the relative humidity percentage less than 25, and another part I have set the temperature less than or equal to 15 degrees Celsius and the subparts as the humidity level greater than 60 and less than 25%. So now if I compile this code, so it has compiled successfully, hence there are no errors. So now let me go to the schematic capture. Now if I first set the data as temperature of 29 degrees Celsius and the percentage humidity as 61. So according to this data, my LED lamp must glow with a time for a time of 0.5 seconds or 5 milliseconds. So if I run it, yeah, the LED lamp is glowing with a period of for a period of 0.5 seconds. So now let me change this data to temperature as 29 degrees Celsius and percentage humidity as 24. Now according to this, my LED lamp must glow with a period for a period of 1000 milliseconds or 1 second. So yeah, it is glowing. The period is 1 second. So now let me again modify this data and set it as temperature 14 degrees Celsius and percentage humidity 62. So according to this, my lamp must glow with for a period of 0.5 seconds. So here it is glowing with a period of 0.5 seconds. Now if I set the data as temperature 14 degrees Celsius and humidity 23, so my all four conditions that I have set in the source code will get checked. So humidity is 23%. So let me run it. It must glow with a period of 1 second. Yeah, so fine. So now if I see this using a virtual terminal, the values of the data would get printed over here. So you can see it is getting printed. So now for the second part of this assignment, I have modified another sample code, that is RGB common cathode LED. I have modified the code as first I have set the pin mode to the output to the 13th pin, and I have adjusted the time period for the LED lamp to get on and get off. So for the first part of the wave, the time for which the LED lamp would remain on is 500 milliseconds or 0.5 seconds, and the time for which it would remain off will be 1 second or 1000 milliseconds. Similarly, for the second part of the wave, the time for which the lamp would remain on would be 250 milliseconds or 0.25 seconds, and the time for which it would remain off is 0.5 seconds. And for the third part of the wave, the time for which the LED lamp would remain on is 2 seconds or 2000 milliseconds, and the time for which it would remain off is 4000 milliseconds or 4 seconds. Now let me compile this code. So it has compiled successfully. Now if I go to the schematic capture and test this, so this is the LED lamp. So first the time period is, this is the second time period. You can see as I have adjusted the time in the source code. So the lamp is remaining off for a long time. This is quite obvious according to the source code. So this is the complete time period, which consists of 3 subparts. So now if I try to visualize it using a digital oscilloscope, so for that first I need to connect this T terminal to the IO13 pin. Now let me run this and visualize it by a digital oscilloscope. You will find, so first I have to adjust in channel D to DC this scale to 0.5 and this millisecond scale to 200 milliseconds. Now you can see that it would consist of 3 waves of different time periods. So this is the first one. The net time period for the first wave will be 1.5 seconds. So this is the second one that has started. The net time period for the second will be 0.75 seconds, and for the last wave, for the third part of the wave, it will be 6 seconds. Hence, if I add all these 3 time periods, the net time period for one single oscillation will be 8.25 seconds. Now this oscillation of 8.25 seconds time period will get repeated every time. So you can see here. So that's it for this assignment. Thank you.